All right, we got the Unit 2 review here. There's a lot of writing initially, so I decided we're just going to go through this here. First of all, you got a conditional statement here, and we're going to write the converse in first and contrapositive. Okay, one thing here is the converse. You want to make sure you flip the order or reverse the order. The inverse, you want to do the opposite meanings of both the hypothesis and conclusion. And then contrapositive, you want to do both of these things. Okay. And then we'll also determine the truth value of these here. So this first one here, usually I'll circle the hypothesis. So that's the part directly after the if, and then the conclusion is the part directly after the then right there. So if an angle has a measure of 60 degrees, then it's an acute angle. All right, so converse, you're going to go and flip that here. So that we're going to say if it is an acute angle, or really you could say, instead of using the word if, you can just say if an angle is acute, then its measure is 60. So all we did was reverse that. You have the inverse here, and that's going to take your original conditional statement right here, and then you're going to do the opposite meanings, or basically throw the word not with both the hypothesis and conclusion. So if an angle does not have a measure of 60 degrees, then it is not an acute angle. And it doesn't literally mean use the word not, it just means use the opposite meaning. So most of the times that's putting not, or you might need to say does not, or something like that. So contrapositive is going to be both of those things at the same time. So that'll be if an angle is not acute, then it is not 60 degrees. Okay, and then you can go and do the truth value of these here. So let's go through those. The conditional, if an angle has a measure of 60, it is an acute angle. That's true. And that's, based off of the, how we define an acute angle. An acute angle is less than 90. Now, if you do the opposite, the converse, if an angle is acute, then its measure is 60. That's not always true, because you could say, what if the angle is like 58 degrees or, 37 degrees or something like that. So that one was false. You have the inverse. If an angle does not have a measure of 60, then the angle is not acute. You could, come up with many examples. So, we could say like 59 degrees. That's not 60, but that's still an acute angle. So that would be a false statement right there. And then you have a contrapositive. If an angle is not acute, then it is not a measure of 60 degrees. So if it's not acute, we're saying like it's right or obtuse. There's no way it could be 60 degrees if we're saying that. So that was true. Okay, and that's how you do all your truth values. Now, if the conditional and converse are both true, I think there's a section with biconditionals. Yep, that's coming up. You can write the biconditional. But with this case, since you have true for the conditional and then false for the converse, it would not be possible to write the biconditional. So this one we'll go through a little bit quicker here. If two angles are congruent, then they are vertical angles. Okay, so that's not necessarily true there in that case right there, because they could possibly be vertical angles. Converse would be if two angles are vertical angles, then they are congruent. Now that is true. All vertical angles are true, or are congruent. So that one is a true statement there. If two angles are not congruent, then they are not vertical angles right there. So that one was true. That's the inverse. And then the contrapositive, if two angles are not vertical angles, then they are not congruent. And that one is false. So next section here is kind of dealing with just rewriting these into a conditional statement, just like above. Key things we need is if and then. So structurally, you will need those, and you will need to have the if as the beginning of the sentence, and then the then needs to be kind of in between. So this right here, a triangle has three sides. So this person wrote, if a polygon is a triangle, then it has three sides. And there's a couple of modifications you can do, but basically we're looking for something that says if and then, and something about triangles having three sides. You could do plastic objects are durable, so you could say if an object is plastic, then it is durable. So once again, keywords looking for if and then, and you start out with if, you end with then. Okay, now like we were saying before, if the converse in a conditional statement are both true, you can write what's called the biconditional. So that's that section coming up here. So you have the conditional of if a triangle has a 90-degree angle, then it is a right triangle. And that's how we define a right triangle, so that's true. And then if a triangle is a right triangle, then it has a 90-degree angle. So the opposite of that, the flip version, is also true. So we can write the biconditional. Big thing you want here structurally for biconditional is you want if and only if. Okay, and that goes between your two statements. That goes between the hypothesis and the conclusion. And technically, it doesn't matter on the order of the hypothesis or conclusion, but if and only if is there. There's no if and then. There's no regular if and then. So it's a triangle has a 90-degree angle if and only if it is a right triangle. Notice that there's not like a traditional if at the very beginning, and there's not a then at the middle of that. So that is biconditional right there. Only one example, so you might want to try another one, from an old homework. Okay, next section here is dealing with counterexamples. So counterexamples are just something that shows that a statement or a conjecture is not always true. So someone says here, if the angle is obtuse and the measure is 120, so there are many obtuse angles that are not 120 degrees. This person put 100 degrees. You could put 100 degrees. You could put 150 degrees. You could put 91 degrees. Any type of angle that's obtuse but not 120 would be a counterexample. Okay. You got if a figure is a rectangle, then it's a square. Not every rectangle is a square right there. Here's an example that's not a square. It's just a traditional rectangle. It's still got your four right angles, but the sides aren't the same length, so not a square. The average of any two consecutive numbers is an even number. So we're trying to see, is this last number here an even if we take two consecutive numbers, or two consecutive even numbers right there and average them out. So they did 2 and 4, so 2 plus 4 divided by 2, that's going to be 6 over 2, which is 3. So that would be a counterexample. And there's many, many counterexamples for that. Four-sided polygon is a square. There's plenty of four-sided polygons that are not squares. You could have rhombuses, kites, trapezoids, rectangles. So there are multiple answers for these. If an animal is a panther, then it lives in the forest. This one's less mathy here. The counterexample is you could say maybe the panther lives in the zoo or something like that. I don't know. Or, maybe someone's got a pet panther. I'm not sure if anyone does out there, but yeah, there you go. Next, you got some pattern recognition. You'll have a few of these. Some of them with shapes, and then some of them here with numbers. So these are pretty straightforward here. On this one here, it appears. There's a couple ways you can describe this here. You could say, looks like each time you're adding 111. So you could go ahead and put that, Or you could even say increase the first two numbers by 1 and then increase the last number by 1. So 557 and 668. This one right here, let's look here. Okay, yeah, I think I see what's going on here. You're going adding 2 between those. This one you're adding 3, adding 4. Between those, 13 and 18, adding 5. So it looks like you're increasing the difference each time by 1. So this next one would have been adding 6, aka getting 24, and then the next one adding 7, getting you 31. Okay, sometimes you'll have these ones here. It's 5, 10, 15, 20. So it looks like this is just kind of like a traditional adding 5 every single time. So of course you get 25 and 30. Okay. Next one, this one's a little interesting here if you're not looking out for it. This one's not adding a consistent number, but what I noticed here is, I believe each of these here being multiplied by 3, right? 2 times 3 is 6. 6 times 3 is 18. 18 times 3 should be 54. So then you can go get those next ones. 54, I guess, times 3. I don't have a calculator with me, but that is apparently 162. And then 162 times 3 is the 486. Okay. This one's another multiply. This one's multiplying each time, but it's multiplying by a negative number because the signs are switching. So you can say that's times -3 times -3 every time. If you want to use, instead of x, so you don't think that's x minus 3, you could do like a dot for times 3. It's totally fine. So times negative 3, so you can keep it going. Positive 243, negative 729. So a couple more patterns here that we'll look at, and then I'll cut it off here at that point. So sketch the next figure in the pattern. So it looks like every one of these here are a circle, but you're adding on, I guess, like maybe an extra radius, if you want to call it that, right there, each time. So this one's got, 2 extra lines. This one's got 3 extra lines, 4 extra lines. So the next one should have 5 different radiuses going on. Okay, it looks like 17. It looks like you are adding these little blocks on every time, and it looks like, I guess, only one of them is white, and then all the other ones are shaded. So you can kind of follow along here. They're, adding one, they're adding one to the right, adding one up there. So it looks like you're kind of adding to the bottom right each time, and then the shaded one, or the unshaded one's moving in different spots. So I guess, yeah, they got that there to the right. This one's kind of like one of these weird ones where you got, shapes inside of shapes. You start with the square, got the circle inside, got the square inside of the circle, and the next one, and then a circle inside of that square. So you can keep it going there, and I guess they're kind of alternating how they shade. So that's that on your pattern recognition.